In this video, I'm going to talk about some of the most common functions and their horizontal and vertical shifts or transformations. A very important part about understanding transformations of functions is to first understand the parent functions themselves. For instance, the equation y equals x, we should understand that that is a diagonal line going right through the origin. Some important points to know on this line are when x is -1, that means y is also -1. When x is 0, that means y equals 0. And another key point is 1, 1. Of course, 2, 2, 3, 3, 4, 4, and so forth are also on this line, as well as their negatives. So that is the parent function of y equals x. You should be able to recognize some key points so that when we transform this function, you know what the original function is. Y equals x squared is another important parent function to know. When x equals 0, y equals 0, so 0, 0 is also contained on this function. When x is 1, 1 squared is 1, which is y, so 1, 1 is also on this parent function. However, -1, when you square it, we square the negative, and so -1 ends up at the value 1. It's important to note that y equals absolute value of x has these same 3 points. The absolute value of 0, 0, the absolute value of 1 is 1, and the absolute value of -1 is also 1. So these 3 key points are on both of these functions. When x is 2 in the y equals x squared function, y would be 4. And when x is -2, -2 squared is also positive 4. So y equals x squared graphs into a parabola. Plugging in a few more points into y equals absolute value of x, we get 2, absolute value of 2 is 2, and absolute value of -2 is also 2. It is actually a V shape. So these are 3 of the most common parent functions. Let's look at a few more before we get into the transformations of these functions. To see the graph of y equals x cubed, the cubic function, we can substitute some x values. When x is 0, 0 cubed is 0. When x is 1, 1 times 1 times 1 is also 1. So the point 1, 1 is on the graph of the function. And when x is 2, 2 times 2 times 2 is all the way up at 8. So the graph is taking off quite quickly here. Now when x is -1, -1 cubed is -1. And when x is -2, we're down at -8. So the cubic function looks something like this. And again, some key points are 0, 0, 1, 1, -1, -1, and 2, 8, as well as -2, -8. Now let's look at the graph of y equals square root of x. For this graph, it's easiest to pick some perfect squares for x since we're taking the square root of x, such as 9, 4, and 1. 0, 0 is also on this function. So for y equals square root of x, the square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. If we went further out, 5, 6, 7, 8, 9, the square root of 9 is 3, and that point is on the function. Since we can't get a negative when we take a square root, this graph will only be in the positive region. So this is the graph of the parent function y equals square root of x. Now let's take a look at the graph of y equals cube root of x. We can pick some perfect cubes for x, such as 8, 1, 0, and even -1 and -8. So substituting an 8 in here for x, the cube root of 8 is 2, the cube root of 1 is 1, the cube root of 0 is 0, and the cube root of -1 is -1. The cube root of -8 is -2, since -2 times -2 times -2 is -8. 0, 0 is on the graph, so is 1, 1, and -1, -1. But we can see we have to go all the way over to 8 to get up to the value 2, and all the way over to -8 to go down to -2. Basically, the function looks something like this. So this is the graph of the parent function y equals cube root of x. Knowing your basic parent functions will help you when you're doing transformations of these functions. First, I'm going to start off with the f of x equals x squared function, which is the same as y equals x squared. This is the most basic form of the quadratic function. We can graph this function by either using a graphing calculator or making a table of values. These are the 5 points that I plotted here. So this is how I came up with the original graph for y equals x squared. Now let's take a look at some transformations of this function. For instance, let's try to graph the function g of x equals x squared minus 4. We could still plug this into a graphing calculator or make a table of values, but the goal of transformations is to be able to locate the transformed graph just by looking at the equation. When a number is being added or subtracted from the end of an equation, it simply moves the graph vertically up or down. Positives go up, negatives go down. So this is just saying to decrease every point by 4. So if we take these 5 key points and drop them down 4, that will be the graph of this function. So the point 1, 1 will go down 1, 2, 3, 4, and it will be graphed at 1, -3. And this one here, again going down 1, 2, 3, 4, will be graphed at -1, -3. These 2 high points here were found by 2, 4, and -2, 4. So if we drop them down, they will be right at the x-axis. They're at height 4, so they would drop down to 0. So this will be our transformed graph of this equation. You could check this by making a table of values. For -2, if you squared it, you would get 4. Take away 4 would give us 0. For -1, if you squared it, you would get 1. Minus 4 would be -3. If we substituted in 0, we would have 0 squared minus 4, which is this one here, -4. And when x is 1, if we squared it and subtracted 4, we would get -3. And when x is 2, 2 squared minus 4 would give us 0. So g of x is simply shifted down 4 because of the subtraction of 4. Now let's take a look at a horizontal shift. Although positives go right on a number line, this plus here will actually make our graph shift left. This is true of all functions. First, I'll make a table of values to demonstrate this. X being -2 would make this 0. So that's kind of what we want as our middle point instead of the middle value of 0. 0, -1, -2, -3, and -4. And calculate some values. When x is 0, 0 plus 2 is 2, and we square that to get 4. When x is -1, -1 plus 2 is 1, we square that to get 1. And of course, -2 plus 2 is 0. -3 plus 2 is -1, but -1 times -1 is 1. And -4 plus 2 is -2. -2 times -2 is +4. So you can see we're getting some values at the same height, which will give us our curve that we're looking for. So that's why it's important to pick the middle value for x to be whatever would make this equation 0. So let's graph these. Over 0 up 4 is this point. Over to -1 up 1 is this point. Over to -2 up 0 is here. Over to -3 up 1 is here. So basically, when we have a number added inside our squaring function, it doesn't go 2 to the right, it actually goes 2 to the left. This is true of all functions. Next, we'll look at putting two transformations together, a horizontal shift of 2 and a vertical shift of 1. If you recall, numbers added to the outside of the function are vertical shifts up or down. A positive will tell us to shift all of these points up. The -2 inside the parentheses is telling us to go opposite of how it goes on a number line. -2 goes left on the number line, but this shift will actually go horizontally to the right. The transformation g of x will go right 2 and up 1. So we don't even have to calculate a table of values knowing this information. We could take the point 0, 0, go up 1 and over 2, and we know that that is where the vertex of this function will be. We could take the point 1, 1 and go right 2 and up 1, and we know it will land right here. We could take this point, -1, 1, shift it right 2 and up 1, and know that it will land right here. And we could take this point, -2, 4, shift it 2 to the right and up 1, and it will land right here on the y-axis. And the point 2, 4 will shift up 1 and over 2 as well. So here is our new transformed graph. Next, let's take a look at some examples working with the absolute value function. Since the basic absolute value function is a V shape going out from 0, 0 with points 1, 1 and -1, -1 on the graph, we can easily transform this V by using our transformations. Any number being added or subtracted to the end of the function is an up or down. Positives go up, negatives go down. So this will be moving the 0, 0 point and transforming it up 3. Any value added or subtracted inside the absolute value bars is a left or right movement. And it's always the opposite of what you would think in terms of the number line. Since a number line, negatives go left, this will actually be going right 4. So we now know this graph will go right 4 and up 3. Our vertex 0, 0 will be going up 3 and over to the right 4. Realizing that in the original function, from the vertex we just rise 1 and run 1, so our transform function, we can just go over 1 to 5 and up 1 to the value 4 to find another point. Similarly, we can go over to the left to 3 and up 1 to find a third point. This is where our transform function will be. So just remember that the values being added or subtracted inside either an absolute value, a square root, squaring, cube root, cubing, those are all horizontal movements. They're called translations. They will move the graph left or right, negatives will go right, and positives will go left. Another way to say that is that minus will go right and plus will go left. And values at the end are vertical movements. They will go up or down. Adding values to the end of a function will cause the graph to go up, and subtracting values from the end of the function will cause the graph to go down. These are key things to look out for in all transformations. Next, let's take a look at a transformation of the square root function. As we know, values added or subtracted inside the function, in this case the square root, are horizontal movements. Plus goes left. So this is telling us to move the graph left 1. The -2 outside of the square root function tells us to move the graph down 2. The 0, 0 point that is on the square root function will be transformed left 1 and down 2. Recall that 1, 1 was also another point on this parent function. The point 1, 1 that is also on the square root function will be transformed left 1 and down 2 to the point 0, negative 1. The point 4, 2 on the parent function will get transformed left 1 to the value 3 on the x-axis and down 2. So it'll actually be lying right on the x-axis at 3, 0. So we now have enough points to draw our transformed function. We could double check that these points are graphed correctly. When x is 0, we will get square root of 1 minus 2, and 1 minus 2 is negative 1. So the point over 0 down 1 is drawn right here, so that's correct. When x is negative 1, we get negative 1 plus 1 under the square root. So we'll get square root of 0 minus 2, which is negative 2, and that's the point negative 1, negative 2 down here. And then when x is 3, we get 3 plus 1 under the square root. Square root 4 is 2, and 2 minus 2 is 0. So that's this point. So these 3 points check out, and there's a rough sketch of our transform function. Here are 2 more transformations. Feel free to pause the video and try these on your own. What does this minus 8 do inside this cube function? Let me know what you think in the comments below. What does the positive 6 at the end of this function do? Let me know what you think. If you said the minus 8 will move the graph right 8, you're correct. And the plus 6 will move the graph up 6. So your cube root function will end up moving over to 8 and up to 6, which is right here. We can easily find 2 more points by going up 1 over 1 and left 1 down 1. So up 1 over 1 would be on this graph, and left 1 down 1 would also be on this graph. So our transform function would look something like this. How about this last one? What does the plus 4 under the cube root function do? And how about the minus 2? Let me know what you think below in the comments. If you said plus 4 makes the graph go left 4, you're correct. And the minus 2 at the end makes the graph go down 2. Using this information, I will let you graph that one on your own. I hope you found this video helpful. Please subscribe for more math tips.